Can AI really think? No, but understanding why it can't think is more important than the answer. Because that single distinction explains almost everything people get wrong about AI. Why it sounds intelligent, why it makes confident mistakes, why it hallucinates facts, why some people fear it, and why others overestimate it. Most debates about AI start in the wrong place. They assume that producing fluent language means thinking. It doesn't. AI doesn't understand what it's saying. It doesn't have beliefs. It doesn't have goals. It doesn't have awareness. What it does have is prediction. It looks at the words so far and calculates the most likely next token. That's the mechanism. And once you see that clearly, you stop confusing fluency with intelligence. AI doesn't think. It predicts. And in this video, I'm going to show you exactly what that means. Before we decide whether AI can think, we need to define what thinking actually is. Thinking isn't just producing an answer. A calculator produces answers. That doesn't mean it thinks. Autocorrect predicts your next word. That doesn't mean it understands you. Thinking involves understanding. It means knowing what your words refer to. It means having some internal model of reality. If I say, "The glass fell off the table," you don't just process the sentence. You understand gravity. You understand physical space. You understand that objects fall downward. You can imagine the event. You can explain why it happened. You could even predict what would happen if the table were higher. That's thinking. Thinking also involves intention. When a human answers a question, they are trying to achieve something. To inform, to persuade, to clarify. There is purpose behind the response. And thinking involves awareness of consequences. If you say something harmful, you understand it might affect someone. You can reflect. You can reconsider. You can change your mind. Even when humans are wrong, they are wrong within a framework of meaning. They are operating inside understanding. So when people ask whether AI thinks, what they're really asking is this: does it understand what it's saying? Does it know why its answers make sense? Does it have goals? Does it have awareness? That's the standard we're comparing against. Now let's look at what a large language model actually does. It processes text as tokens, not ideas, not meaning. Tokens. A token can be a whole word, sometimes just part of a word, sometimes punctuation. The model doesn't see sentences the way you do. It doesn't see grammar. It doesn't see concepts. It sees sequences, symbol sequences. When you type a prompt, the system does not interpret your intent. It does not pause to consider meaning. It does not reflect. It performs a statistical calculation. Given this sequence of tokens, what token is most likely to appear next? Behind the scenes, thousands of possible next tokens are considered. You never see them, but they're there. Each possible continuation is assigned a probability score. Those scores are based on patterns the model observed during training, not on understanding, on frequency and relationships in data. Some tokens receive very high probabilities. Most receive very low probabilities. A few are mathematically possible, but extremely unlikely. This ranked list of possibilities is called a probability distribution. It is simply a structured list of weighted options. Now let's make it concrete. If you type, "The cat sat on the model doesn't imagine a cat. It doesn't picture a mat. It doesn't recall reading that sentence in school. It evaluates probabilities. Mat gets a high score. Floor gets a lower score. Chair gets a smaller one. Moon gets a near zero score." Not because it understands cats, but because in the massive data set it was trained on, certain sequences appeared more often than others. The model then selects one of the higher probability tokens. Then it appends that token to the sequence. Now the sentence becomes, the cat sat on the mat, and the entire process starts again. Thousands of possible next tokens. Again, probability scores assigned. Again, one token selected. This happens for every single word in a response, from the first word to the last. One prediction at a time. There is no internal narrator, no visualization, no mental simulation, no conscious reasoning process. Just probability calculations layered sequentially at extraordinary speed. That's the mechanism, not thought. Prediction. People often say, but it was trained on books. Yes, it learned from experts. That sounds impressive, but training on text is not the same as understanding the world. AI is trained by adjusting parameters so that its predictions improve over time. It does not read a book the way you read a book. It does not pause and reflect on meaning. It does not ask questions. It processes text as patterns, relationships between symbols. If the word doctor often appears near the word hospital, the model strengthens that association. If Jupiter often follows largest planet, that relationship becomes statistically strong. But statistics are not understanding. The model does not know what a hospital looks like. It does not know what a planet is. It cannot imagine space. It cannot feel temperature. It has never experienced gravity. It has never experienced anything. Humans ground language in perception. You learned what hot means because you felt heat. You learned what falling means because you dropped something. Language connects to reality through experience. AI has no experience. It only has correlations between symbols. And correlations can be powerful, but they are still just patterns. It's important to understand something here. The model learns correlations, not causes. If two words frequently appear together, the connection strengthens. But the model does not know why they are connected. It doesn't know that gravity causes objects to fall. It only knows that in text, fall often appears near gravity. That's correlation, not comprehension. Humans build models of cause and effect. AI builds maps of statistical proximity. Those are not the same thing. That's why a model can write a convincing essay about a place it has never seen. It's not recalling memories. It's reconstructing likely patterns based on similar text. When it describes a beach sunset, it's not seeing the sun. It's predicting what beach descriptions usually sound like. Training improves prediction accuracy. It does not create awareness. It does not create intention. It does not create understanding. The model becomes better at mapping relationships in data, but it never steps outside those relationships. It never knows that the words refer to something real. That's the difference between learning patterns and understanding the world. AI has the first, not the second. So if AI doesn't understand anything, why does it feel intelligent? Because language is the surface of thinking, and AI has mastered the surface. It has learned patterns of explanation, patterns of argument, patterns of persuasion, patterns of empathy. It has seen millions of examples of humans explaining things clearly. So it learned what clear explanations look like. It has seen structured essays, structured debates, structured answers. So it learned that structure. When you ask it a question, it predicts a response that matches those patterns. And to your brain, that pattern looks like reasoning. Humans are extremely sensitive to fluency. If something speaks smoothly, we assume it understands. If something sounds confident, we assume it knows. If something answers quickly, we assume it is intelligent. Speed reinforces the illusion. AI responds in seconds. That feels like expertise. Consistency reinforces the illusion. It rarely hesitates. It rarely says, I don't know. That feels like certainty. Structure reinforces the illusion. Clear paragraphs, logical progression, step-by-step answers. That feels like thought. But all of those signals are surface features. They are patterns in language. AI was optimized to reduce prediction error, to produce text that statistically matches what humans expect to read. It was not optimized to build internal models of reality, not to reflect, not to question itself. When it generates a structured explanation, it isn't thinking through the steps. It is predicting what a structured explanation typically looks like. Your brain fills in the rest. You attribute intention. You attribute awareness. You attribute intelligence. This is called anthropomorphism. We project human qualities onto non-human systems. We do it with animals. We do it with cars. We even do it with weather. So when a system produces language that resembles thought, we instinctively treat it as if it is thinking. But resemblance is not identity. Fluency is not comprehension. Structure is not awareness. Confidence is not certainty. Coherence is not understanding. AI doesn't sound intelligent because it understands. It sounds intelligent because it has learned what intelligent writing looks like. And at scale, that illusion becomes powerful. But it is still an illusion, not thought, prediction. If you want AI explained without hype or fear, just mechanisms, subscribe. That's what this channel is built for. At this point, some people say, but it explains its reasoning. It shows its steps. So it must be thinking. That feels persuasive. Because when humans explain their reasoning, they are describing an internal thought process. They think first, then they explain what they were thinking. There is a separation between thought and language. With AI, that separation does not exist. When a language model generates a step-by-step explanation, it is not revealing hidden thoughts. It is generating a structured pattern. It has seen thousands of examples of human reasoning written out in text, math solutions, legal arguments, scientific explanations, debate responses, tutorials. From that data, it learned. It learned what reasoning typically looks like. It learned that explanations often follow structure. First, define the problem, then outline the steps, then justify the conclusion. That structure becomes statistically predictable. So when you ask it to show its reasoning, it predicts that format. Not because it internally reasoned, but because that pattern appears frequently in training data. The explanation and the answer are generated together, token by token. There is no hidden internal layer where the model thinks silently and then translates those thoughts into language. The reasoning is the output. It is not a window into a mind. This is also why models can pass exams. Exams reward structured pattern recognition. They reward applying familiar formats to recognizable problem types. AI is very good at that, but passing a structured test is not proof of understanding. It is proof of pattern mastery. And pattern mastery is not the same as awareness. That's why sometimes a model produces a beautifully structured answer that contains subtle mistakes. Because the structure of reasoning can be reproduced even when the underlying logic is flawed. It is simulating the form of reasoning, not performing reasoning in the human sense. Humans reason by building mental models, testing assumptions, reflecting on consequences. AI generates text that statistically resembles that process. Explanation does not equal understanding. It equals pattern reproduction, and pattern reproduction is not thought. This distinction isn't academic. It changes how you interpret everything AI does. If AI doesn't think, it doesn't have goals. It doesn't wake up with intentions. It doesn't want power. It doesn't desire control. It doesn't intend harm. When it produces something harmful, it is completing patterns. When it hallucinates, it is completing patterns. When it sounds confident, it is completing patterns. That matters because prediction at scale is powerful. It can draft emails, summarize reports, generate code, translate languages, automate structured tasks. Can it replace certain tasks? Yes, because many tasks are structured pattern completion, writing routine responses, summarizing predictable formats, applying familiar frameworks. Prediction is good at that, but replacing a task is not the same as possessing judgment. Judgment requires context. Context requires understanding. Understanding requires awareness. And awareness requires thinking. AI does not have that layer. It has prediction, and prediction can be extremely useful. It can accelerate work. It can enhance productivity. It can reduce friction. It can assist human decision-making. But it does not replace human responsibility because it does not know what it is doing. It does not know why it is doing it. It does not know whether it is correct. It predicts. That's the core. So can AI really think? No, it predicts. If this helped, subscribe and start with this video next. AI doesn't think. It predicts.